Bismillahirrahmanirrahim. Welcome to the sixth lecture of Statistics and Probability Theory. In previous lecture, we have studied Bayes' theorem. We defined that, let's suppose we have a sample space S. Whole sample space is divided into some mutually exclusive and exhaustive events. Let's suppose this one A1. This one is A2 up to so on. There can be n mutually exclusive and collectively exhaustive events. Mutually exclusive means when we take intersection of this A1, intersection A2 up to so on, intersection AN, it would be empty set. And exhaustive means when you take their union A1 union A2 up to so on union AN, there it would again give you the sample space S. All these sets are non-overlapping. Let's suppose there is some other event B defined on the same sample space. So whenever B will occur, any of the I will occur where I is equal to 1 to n. So Bayes' theorem tells us this, or it helps us to find out that if we know that B is happening, what is the probability that AI is occurring? Let's suppose if we substitute I is equal to 1, it means that we know that B is occurring. What is the probability that A1 is occurring with the B? Or when we substitute I is equal to 2, it means that we know that B is already occurred. What is the probability that A2 is occurring with it? It would be equal to probability of AI into probability of B given AI whole divided by summation I is equal to 1 to n with probability AI into probability B given AI. So this is called the Bayes theorem. Whenever the event B is occurring, any of the A will occur with it. Bayes theorem will help you to find out which of the AI is occurring with it. In today's lecture, we're gonna study reliability of system, and we will use some previous examples which we already discussed in previous topics to understand the reliability of the system. Reliability of the system. Reliability of a product is defined as the probability that product will not fail throughout a prescribed operating period. Most products are made up of a number of components. The reliability of each component and the configuration of the system consisting of these components determines the system reliability, that is, the reliability of the product. The components may be in series or parallel or combination of series and parallel. What is series? System performs satisfactory if all components are fully functional. For example, a switched ceiling light. Parallel system performs if any one component remains operational. For example, an airplane with 4 engines or a laptop with a power source and a battery. Example number 1. Let's suppose this is a system. Find the reliability of the above system if the reliability of each component is 96% and components are working independently. As components are connected in series, that is, whenever the system will be in working condition, it would be in series from A to B to C. So let W represent the system works. Let's say we are defining this event that the system will work represented by W. A represents that component A works. B represents that component B works. C represents that component C works. So we have to find out the reliability of the system. That is, probability that system will work. Now you can see from here that system will work when all the three components will work together. It means that A and B and C should work together. This is the way the system would be reliable or it would work. So R represents the reliability. P probability of W means W represents the system works is equal to probability A and B and C. As we know that this is the series and they should work together in order to maintain the system or the system make the system to work. So it would be probability A intersection B intersection C. Now, as we know that from the example statement of the example that components are working independently. So from here it is probability A intersection B intersection C. If you recall the multiplicative law, so how we can open it? Probability of A into probability of into probability of B given that A has already occurred into probability C is occurring given that A and C have already occurred. As it is defined in the statement that system is components are working independently. So from independent and dependent event topic, you can recall that it would be equal to probability of A into probability of B. This probability B given A will be equal to probability of B because A and B are independent. So the statement says that probability B given A, or we can say that probability that B is occurring given that A has already occurred. As A and B are independent, so it does not affect that A is occurring or not to the B. So now this would also equal to probability of C. So this would be equal to probability of A into probability of B into probability of C. We know that each component reliability is 96%. It means 0.96. So probability of A is 0.96, probability of B is 0.96, probability of C is 0.96. So this would be equal to 0.8847. This is the probability that system will work. Example number 2. Find the reliability of given system. This would be the system. This would be the system. If the reliability of each component is 96%, as you can see from the diagram, there are two components A, B, and components are working independently. Solution. As components are connected in parallel, this is the complete system. This system can work if system starts from here, goes to A, and the system can rely on A, or this could start from here, goes from here, then to B, then to the end. So this is the parallel system. If you go to the previous example, you can see from the diagram that this process, if the process will start from here, it would go to A and B and C. Otherwise, you can't reach here. But in this case, you can reach here either through this way or through this way. So this is the parallel system. Parallel. So the system will work if any component of system will work. It means that if A will work, system will operate accurately. Or if B will work, system will operate accurately. Let W represent that system works, A represent that component A works, B represent that component B works. So reliability is equal to probability that system will work. So R is equal to probability of W, as we know that W means the system works. So we know that if any one of the components will work or operate, the system would be reliable. That is, if A will work or B will work. So we know that whenever OR will use, it means union. Probability A union B. If you remind addition law of probability, this means that probability that A will occur or B will occur or both will occur. So by applying the addition law of probability, this would equal to probability of A plus probability of B minus probability of A intersection B. Now, we know the probability of A, we know the probability of B. What about this probability A intersection B? This could be sought out from the statement that components are working independently. If the components are working independently, so by the multiplicative law, we know that probability A intersection B would be equal to probability of A into probability of B. So by substituting the probability, as we know that each component is working with the probability 0.96, so 0.96 plus 0.96 minus 0.96 into 0.96, it would be equal to 0.9984. This is the probability that system will work.